Recording in progress.
Okay, for this question, why I change it to this form and how I change it is because x squared is the same as square root of x to the power 4. Okay, and I change it to this form so that see another one. I'm tired of. Correct? I have this. So that when I differentiate this, I just need to use chain rule. Correct? If this one, I have to use product rule. Am I right? Okay. And there is also another way. Instead of doing like that, there is also another way. So if this one I differentiate, then I just need to use chain rule. So it saves a lot of my time. Right? Right? There is another way also. So you see, whenever we do differentiation, whenever we do calculus, we always think we try to avoid product rule or quotient rule. Why? Because there's a lot of steps, a lot of process need to be carried out. So if you next time you are the programmer, you want the program to run fast. So you try to reduce the step. So that is called the loop. Yeah, I know this because my youngest brother, he is a programmer. So sometimes he sit there and think of how to do, then he will ask me because it involves maths, it involves logical thinking. So he will ask me, can I do it this way mathematically? So you see, when you learn maths, why you want to be a programmer, maths is very important. It's like that. It's not the maths knowledge, it's the training that you have for maths. Okay, for this one, now I can think of there is another way. Still remember, I told you, if you want to make the differentiation of this much easier, what you can do? Yeah, you are right. I can also, this is the usual method that we use. Okay, we also can let k be equal to y squared. Am I right? So I have my k will be equal to x to the power of 4, 1 minus x. This is so much better. If k is, this question is talking about, oh, no. I can't do that for this one. Unless, cannot. Do you know why? This is only done when we talk about what? Maximum or minimum. Is this question talking about maximum or minimum? So you can't. So you see, I didn't look at it carefully. Only talk about maximum and minimum, then you can do like that. But this question is talking about find the equation of tangent, so you can't. So you only have this choice. So I differentiate it, then I straight away substitute with my x equal to -3. So it will make the whole thing easier and faster. Are you clear? Okay, done with that. Okay, okay, so there's a request from your friend, ask me to explain practice 2, question 3. Okay, when come to curve property, there is a lot of things that you have to bear in mind. Okay, now I will start by, okay, this question, usually for curve property question, we don't put it in a context, but this one, I put it in a context of velocity. Say, an object is moving in a straight line such that its velocity. So the velocity go in this way. So how do you interpret this? How do you interpret this graph, first of all? Yeah, next cubic graph, okay. We are talking about context. In this context, may I know when the particles stop moving? So when the question is contextual, you have to interpret according to the context. Okay, I know that V2 is equal to 0. And I know that V6 is also equal to 0. Am I right? That is one thing. Okay, now. And I know that for T between 0 and 2, the particle is moving to the left or to the right. Are you sure? Are you sure the particle is moving to the left? Because you don't just copy. You can see this again. You can go and download and screenshot it. Because what? Because VT is greater than 0. Am I right? How I know VT is greater than 0? The VT graph is above the t-axis. Am I right? So you have to look at what is the graph given to you. So now, I just interpret one part for you to see. Okay, I will ask you this question from the graph. I will ask myself this: when is the velocity minimum? When is the velocity minimum? Local minimum and local maximum. When x equal to c and maximum, local maximum for velocity is when x equal to 6, when t equal to 6. Am I right? Okay, now to answer part A. So you see contextual question, you have to look at the context. Okay, what is the relationship between acceleration and velocity? This question is very nice. Correct? don't want to tell you how is acceleration related to velocity. You should know. But this question tells you very nicely. Acceleration is the rate of change of velocity. Am I right? So you want to draw the acceleration sign diagram or draw the graph. So before I draw the graph of acceleration on the same axis, what I should do? I should produce a sign diagram for acceleration first. Am I right? So I will produce a sign diagram, t greater than 0 onward. Okay, so I have to ask myself, when is acceleration equal to 0? So your friend answers C and 6. So I mark down here C, mark down here 6. Okay, so to know the sign, correct? If the velocity graph is going down, it means acceleration is positive or negative. Am I right? If the velocity graph is going up, that is C to 6, then the acceleration will be positive because increasing velocity. Then go down. So if I sketch the graph, I will know that my acceleration graph will pass through this point and pass through this point. I mark down. All right. For 0 to C, it is below the x-axis. So it will be here. And this is a cubic for velocity. So acceleration will be quadratic. You try not to do graph on graph. Produce the sign diagram first, then you will know how it goes. Two marks, 3 minutes. 1 minute on sign diagram, and then you can draw the graph accurately. Why not? Am I right? You see or not? So analyze the graph property, curve property. All these, sign diagram play a very important role. Will I give mark on the sign diagram? Will I give mark on the sign diagram? The answer is no. But sign diagram can help me to get the right answer. Should I do it? Even mark is not awarded. The answer is a yes. You see or not? Okay, so that is done with part A. Okay, part B. Also 2 marks only. These 2 marks is not easy to earn. Okay, now. But that doesn't mean you don't learn, okay? Okay, for part B, this is harder to do, correct? So now, if you want to get the displacement, correct? So if you want to get the displacement graph, what I must have 2 sign diagrams. Okay, so now I produce the velocity sign diagram first. So I know I have to mark down these 2, correct? So I mark down 2 and 6. Okay, the velocity graph is above the t-axis. So positive, negative, negative. Am I right? Hello? Is my sign diagram for velocity correct? Okay, so which means that my are you okay? So look, for this one, from the graph shown below, which graph best describe the displacement of the object? Explain your answer. So how I explain my answer? I draw the sign diagram of VT. And I explain. That's it. Explain in maths, correct? Doesn't mean always must be in words, not English. You can use different form. I can explain in the form of a graph. Diagrams speak 1,000 words. Am I right? Done. So that's why I told you how important is sign diagram. Depend on what is given. So this is a question. Look. So I start with, I write down area of rectangle OBPBA. Up to you how you want. Okay, I let it be A, and I want to write it in terms of X. Okay, huh? So I will write down AX equal to, so you want to find the area of a rectangle will be length times breadth. So I will say OA times AP. Okay? OA times AP. Okay, so now I have to know what is OA. So I will tell myself that OA is equal to BP. All right? And coordinates of P is X. I let the X coordinate of P be X, and the Y coordinates of P will be e to the power of what? Negative X. So I will write down OA is X. All right? And my AP is the Y coordinate of P, am I right? Okay, so how do you get 2 marks for this? you get 2 marks for this by writing out this and this. You get 2 marks. This formula, you won't get 1 mark. Why? Because it's given in the question. So if the question asks you to show, correct, you must learn how to tell the examiner how you get these 2. So the 2 marks is there. Or you can label in the diagram also, I will give you a mark there. Or you can say AP is equal to Y coordinates of P. That will be much better. You see how you present your answer? Okay, done. Okay, then find the coordinates of P when rectangle OABP has a maximum. So the part B. So whenever you have this type of question in the exam, if you can't do part A, can you continue with part B? The answer is a yes. Because I have the formula. So what you should do? First step, find the derivative of the area, rate of change of the area. And in this case, what rule do you use? Product rule, do lah. Okay. So very sad to say that there are still many in this class don't know how to use product rule. Okay. So product rule, you have your U and your V. So this is your U, this is your V. Okay. V U prime plus U V prime. Right? So you factorize out the common factor. I told you already. So I have e to the power x, negative x, open bracket, 1 minus x. Straight away, what I do? When I want to talk about maximum, minimum, straight away, what must I do? Equal to 0. So there are 2 components here. Negative x equal to 0. So down here, I write down no solution, correct? Or impossible. And here I write 1 minus x equal to 0, x equal to 1. Okay, then after that, I have to draw the sign diagram of A prime x. So if you look at here, x must be greater than 0, am I right? So I start from 0 onward, and I put a 1 here. What the question talking about? Maximum area. So maximum here must be positive, here must be negative. That's it. You don't have to specially go and test the sign. Yeah. So then they say find the coordinates of P. Therefore, coordinates of P will be x equal to 1, y equal to e to the power negative 1. Done. So that is where you get your 4 marks. You differentiate correctly, 1 mark. Equate equal to 0, get 1 mark. Got your x, got your coordinate. You see, that's why I can mark very fast one. I know where to tick. Are you okay? So tomorrow, tomorrow lecture, tomorrow tutorial, okay, I will give you some function, important function, and I will show you how to find the rate of change. Okay, important function. There are 3 important functions that you must know how to differentiate. Okay, your exam paper is here. You want to have a look at it? No way. Okay? Thank you, class.